Good morning. All right, so we are leaving exponential functions, which is Unit 4, and we're heading into Unit 5, which talks about the characteristics of all the functions we've done this semester. Linear, those are those straight lines. Quadratic, those are those parabolas. And exponential, those are those J-curves that we just did last week. All right, so the very first section in Unit 5 is a favorite, an old familiar friend, average rate of change. Average rate of change, all that is slope. All right, so all we're going to do today is the slope formula, y to the sky, y2 minus y1 over x2 minus x1. So we need two ordered pairs. We need an x1 and a y1 and an x2 and a y2, and then we can calculate the slope. All right, so let's try some of these. Number one, this is linear, right? Notice it's just 2x, it's not x squared, and then it's not exponential, because if it was exponential, the variable would be the exponent, like 2 to the x versus x squared versus just x, right? So that's linear, quadratic, exponential examples. Anywho, we're going from -2 to 5. Okay. This is interval notation. This is x1 and this is x2. So they want you to go from -2 to +5 on the x-axis. In order to do average rate of change, we need the y-axis numbers for this equation. All right, so we're going to figure out what y is so that we can finish it. Okay, so to figure out what y1 is, let's grab this x1, which is -2, and substitute it in for x. All right, these are our x's. So we have 2 times -2 plus 3. So that's -4. -4 plus 3 is -1. So that's our y1. Now we can figure out what our second y is. All right, so we want to put in this second x, which is 5. So 2 times 5 is 10. 10 plus 3 is 13. So now that we have our x's and our y's, we can do this formula right here. So we want to put the y's on top. So the y's would be 13 minus -1. Then we're going to put the x's on bottom with subtraction. So the x's is 5 minus -2. Okay, so if you have those fancy schmancy calculators, right, these, and you can use the fraction bar, go for it. Or you can just do some good old-fashioned by hand arithmetic. Double negatives turn into positives, so you get 14 over 7. 14 over 7 is 2. So that's your answer right there. All right, the average rate of change from -2 to 5 on the x-axis for this equation is 2. All right, let's try number 2. Ooh, we've got ourselves a quadratic equation, right? X squared. So this is a U shape. All right, we want to know what the average rate of change is from -2 to +1. Notice we have the x's, but we don't know the y's. So here we go. Let's figure out what y1 is by putting in this -2 for any x that we see. All right, so we have 3 times -2 squared plus 2 times -2 plus 6. All right, so notice it went in here, and it had to go in here, anywhere that you see an x. All right, so you could do it by hand, or you could do the calculator. My only concern is if you're on the calculator, you have to use parentheses, or else it doesn't read it correctly. All right, let me show you what I mean. So if you are on these calculators, these parentheses are required, or it won't read this square correctly. Alrighty. Plus 2 times -2 plus 6. All right, so it looks like the first y is 14. All right, now let's figure out what that second y is. So we have 3 times 1 squared plus 2 times 1 plus 6. All right, so 1 squared is just 1. So this is 3 plus 2, so that's 5. 5 plus 6 is 11. All right, so now I'm ready for my slope formula. We want to put y2 minus y1 on top. Y to the sky. So we have 11 minus 14. Then we're going to do x2 minus x1 on the bottom. So 1 minus -2. All right, minus minus becomes plus. And here we go. 11 minus 14 is 3. And on bottom we have 3. Negative 3 divided by positive 3 is negative 1. So we have an average rate of change from negative 2 to 1 of negative 1. So we're on the side of the parabola that's going down, right? It's going down, negative slope. All right, check out number 3. This is exponential. The variable is the exponent. So this is your exponential function. We want to go from 0 to 3 on the x-axis. So what we need then is a y. All right, so this is my first x, this is my second x. So let's find out our first y. We have 2 times 3 to the 0. Anything to the 0 power is 1. So this just comes out as 2. And you can always type it into your calculators to see that. And then the second y, let's see, let's plug 3 in. So we have 2 times 3 to the third. Okay, so be careful with order of operations. You don't want to do 2 times 3. You want to do your exponents first. So you want to do 3 times 3 times 3. Or you could type it in all at once on these calculators. It'll know what to do. But anywho, this is 27. Then you can double that out. So your output is 54. All right. Slope time. So we have y2 minus y1 all over x2 minus x1. So this is 52 over 3. I don't think that reduces to anything pretty, so I'll just leave it like that. All right, so there's your rate of change. Okay, so you've seen interval notation with the brackets. That's just bracket notation for the x-axis. You've seen inequalities, so it's the same idea. And then just straight up telling you what the x's are. So how about you try 4, 5, and 6 on those on your own, and let's move on to number 7. All right, so now we have the points given to us, so we don't have to worry about plugging things in to get the points. The points are ready to go. So this is old school. So this is our first ordered pair, and this is our second ordered pair. All right, notice these are ordered pairs now. It is not the same thing as interval notation where they have the word from with the brackets. All right, they look very similar, but they're different. Okay, so on top we have y2 minus y1 all over x2 minus x1. We have that minus minus going on again, so we can turn that into a plus. So this is negative 19 over 5. You can leave it just like that. You don't have to worry about making it fancy. All right, so let's take a look at number 8. All right, so again, we have our ordered pairs ready to go. So here's our first ordered pair, and here's our second ordered pair. And then we just throw it into that slope formula like we've been doing all year long. So on top we have 5 minus 5 all over 5 minus 2. 0 over 3. So 0 divided by anything is 0. All right, so this slope, this is a flat line, right? If you graph these 2 points, 2, 5, and 5, 5, that's just a flat line, right? 0 slope. It's not rising or running. Well, I guess it's only running, so it's not rising. Okay, so I'll leave you for 9 and 10 then. Let's jump down to charts. All right, we want to do average rate of change from a table. So again, here's that bracket again. This is just telling you where to go on the x-axis, right? That's called interval notation. So we're going from 1 to 3. So I would scribble out any of the other ones so that you don't get distracted. All right. So the formula says to do y2 minus y1 over x2 minus x1, right? That's your slope formula. So the second y is negative 8 minus the first y is negative 4. Now we do the x's. 3 minus 1. Minus minus you can turn positive, so you have negative 4 over 2, which is negative 2 for your answer. You kind of bubble that in so that it pops. All right, number 12. So we're going from negative 2, which is right here, to 0. So scribble out all the rest, right? Get rid of all the noise so that we can focus. Our second y is 16 minus the first y, which is 4. And then on bottom we do the x's. 0 minus negative 2. So 16 minus 4 is 12. Double double becomes positive. 12 divided by 2, 6. All right, number 13. We're going from 30 to 39, so from here to here. Ignore the rest. All right, so our second y is 35 minus the first y, which is 47. And then on bottom, we do the x's. 39 minus 30. All right, so this would be negative 12. And then this would be 9. And then that can reduce by 3, so we have negative 4/3. All right, onward. The last way that we have to do rate of change is from a graph. Okay, so here we have that interval notation again. It's the bracket. So they're saying on the x-axis, they want you to go from 1 to 4. All right, so let's find that on the graph. 1 is right here. 4 is way up here. All right, so those are the 2 points that we're going to do rate of change from. So this first ordered pair is 1, 3. And this ordered pair is 4, 9. Let me rewrite the slope formula here so you don't have to flip. Y to the sky. So y2 minus y1. And then the x's go on bottom. All right, so there's your rate of change formula. Okay, so our second y is 9 minus our first y is 3. Then we do the x's. Our second x is 4 minus our first x, which is 1. So this slope, right, this average rate of change is 6/3. 6 divided by 3 is 2. All right, so from here to here, we're rising 2, run 1, rise 2, run 1, rise 2, run 1. And it's average, though, because there is a dip. All right? Okay. Number 15. We're going from negative 3 to 2 on the x-axis. All right, so negative 3, let's find that right there. And then 2 right there. All right, so this point is negative 3, 4. And then this point is 2, negative 1. And away we go. The second y is negative 1 minus. The first y is 4. The second x is 2 minus. The first x, which is negative 3. Negative, negative goes positive, so we have negative 5 on top, positive 5 on bottom. Negative 5 divided by positive 5 is negative 1. All right, number 16. We're going from 3 to 4 on the graph. So 3 would be right here to 4. 4 is right here. So this point is 3, negative 3. And this point is 4, negative 1. All right, so it doesn't matter which one you declare the first or the second. I always just read it from left to right. So I call this my second point. Anywho, we have negative 1 for the y minus negative 3. Now we do the x's. 4 minus 3. Minus minus becomes positive, so this is a 2/1, which is just 2. Okay. Exponential, whee! We're going from 0 to 2, so 0 is right here. And then 2 way up here. All right, so this is 0, 3. And this guy is 2, 12. All right, so our second y is 12 minus 3. Now we do the x's. 2 minus 0. So that's 9/2. All right. And one more on this side. We're going from negative 4 to positive 4. So negative 4 to positive 4. Okay, so this ordered pair is negative 4, comma, negative 4. And this guy is 4, 0. All right, so our second y is 0 minus. Our first y is negative 4. Then we do the x's. 4 minus negative 4. Minus minus goes positive, so we have 4/8. 4/8, that's the same thing as 1/2.